Hello everyone, Anna's here. Welcome to the first episode of our Unity Science series. Today, we'll embark on a cosmic journey to understand the vastness of space by simulating the real distance and size of the Moon, Earth and Sun. We'll visualize how these celestial bodies relate each other in space. And we'll ever simulate sunrise and sunset from Earth. Let's dive in. So first, let's start with creating two spheres to represent Moon and Earth. So, sphere, Earth, another Moon. Okay, so now we need to understand the size of the Moon and the Earth. Normally, in the space, those distance and radius are so huge, so we cannot represent all here in Unity. But we can do some tricks. So we can use a scale of 1 of million. So to understand this in a good way, so here we have a table that represents some data in which we will use it today. The radius of the Moon in kilometers is about 1,700. and the Earth is 6,300. As I say, it's hard to represent all in Unity because the distance are so huge. So let's create, or let's change the scale. So here, to make things easy, each 1,000 kilometers is about 1 unit of unity. Unit of unity is 1 meter. So need to go to Earth. Instead, here we have 1,000 kilometers. We need more than 6,300 and multiply by 2. By 2. Okay, and we do the same for X and Y and Z. So this is the new scale about Earth, and we will do the same for the Moon. Multiply by 2 because we need diameter. Okay. And now the distance between them so if we want to convert it, so let's set first the Earth is the center of the universe, I mean center of Unity, and the Moon, let's keep it 0, but in X the distance that we choose. So this is the real distance, as you can see here, between the Moon and Earth. From Moon, so we see the Earth in this dimension, but instead from Earth we see the Moon has this size. So now let's change the texture of the Earth, at least the Earth. So I already download in Asset Store an asset that's called planet Earth, and of course it's free. So let's take the high resolution Earth. Okay, and let's keep it as the size of the Earth. I mean the first Earth. Yeah, something like that. And of course we don't need the measuring there of the first sphere that we create. Okay, so now let's put like a witness in the Earth, in the surface of the Earth, to understand how we can see the moon from Earth. So to do that, here let's create like a cube. An equator here, right? And let's put the camera there. So the camera, our camera, need to be in the cube. So let's do like that. Let's resize the cube. Something like that. Right. Now let's put the new camera there. So, and let's see how we can see the moon. So we need to accelerate. So now this is the field of view of the camera. I don't know if we can see the moon. Yeah, we can see the moon from here. The moon is moving because the Earth is moving from here. So if we want, we can stop the Earth, the rotation of the Earth. And we can, yeah, so this is the real, I mean, this is how we can see the moon, as you can see here, from Earth. Maybe we can add field of view. If we change field of view, you see, we can see that effect. But for us, let's do a standard. So this is the real distance between the moon and Earth. They are too far, not as we think before.